Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. I am welcoming you all to this platform. Now, we are happy to announce that Unacademy is going to providing online training for GATE and engineering service exams. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now, here we check how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy. By typing Unacademy, it will show the Unacademy learning app like this. And in this, click on this install button. Once you click on this install button, it will install the Unacademy learning app into your device. Now, what you will get? So by joining this Unacademy, what you are going to get in is here the first and foremost thing is daily live classes. Daily live classes. Now in that, you can chat with your educator. That means you can chat with your faculty. Engage in discussions. You can engage the discussion. And you can ask your doubts. And you can answer polls. So during class is going on, your faculty will ask some of the questions. And some of the questions they will ask. Now, by participating the answering in that question, you can participate in the polls. So it will boost up your confidence. Okay. And the second one is structured courses. This is very, very important. All our courses are structured in line with your exam syllabus to help you best to prepare for it. To help you best to prepare for it. All your courses they are structured in a line with your exam syllabus. Whatever your syllabus you have, that means whatever the content you need to prepare, only they will keep that content only. Unnecessary things they won't add it. So they will remove the unwanted things, and whatever the content you want, they will keep only that one. And it is going to help you best to prepare for it. And the third one is live tests and quizzes. Yeah. Now let us take myself. I prepared a transistor. Now I'm feeling that yeah, I'm very confident about transistor. I'm saying I'm feeling confident. Okay, but how can I get more confidence? I'm saying that I've prepared. How can I know? Am I prepared effectively or not? Am I prepared perfectly or not? By writing more number of tests and quizzes, then only we can estimate our preparation. So for that, to evaluate your preparation with your regular mock tests and quizzes and get a detailed analysis on your performance. After completion of that, by getting a detailed analysis on your performance, you can, from that examinations, you can get that. And last one is unlimited access. Unlimited access. Once you are taking the subscription, you can get an access to all our live and recorded courses. All live and recorded courses to watch from comfort of any of your device. You can take live session as well as recorded session also, you can go for it. You can watch all those things from comfort of any of your devices. Okay, any of your devices. Now see here, there are two subscriptions. One is iconic subscription. Second one is, sorry, iconic subscription, first one, and the second one is plus subscription. So as a plus subscriber, you are going to getting the daily live classes. Daily live classes you can get. Next, structured courses. Structured courses you get it. And live tests. What are the things just before we discuss? And unlimited access. Unlimited access. All these things you can get by taking a plus subscription. So in daily live classes, you can chat with your educators, you can engage the discussions, and you can ask doubts to your faculty, and you can answer the polls also. And in structured course, all our courses are, all your course what you are going to be writing, preparing, is structured in line for your exam syllabus. Next, live tests and quizzes. So to evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance. You can get the detailed analysis on your performance. Next, unlimited access. So once you taking a subscription, by taking subscription, you can access to all our live and recorded courses to watch from the comfort of any of your devices. Okay. So these are the benefits you are getting as a plus subscriber. In iconic subscription, that means as an iconic subscriber, you are getting whatever the facilities getting the plus subscriber. In addition to these facilities, you are getting these things. Three additional things. First one is personal coach. The specialty of iconic plan is we are providing a personal coach to you. So take your GATE and engineering service preparation to next level with personal coach. Here we are providing a personal coach to you. With that help of personal coach, we are taking your preparation to the next level. That means we are taking you close to the best rank. So if you utilize those facilities effectively, then definitely you get the best rank. Next, personal coach. What is the meaning of personal coach? So you get one-on-one guidance. You get one-on-one guidance from top exam experts. He is acting as a personal coach. He is going to do, once you are writing the examination, he is going to analyze that exam what was written by you. Okay, and after the analysis, they will prepare strategy and learning resources. That means they will prepare proper study plan to you, and respect to resource also they will provide. Respect to resource means respect to study material also they will provide. That is the purpose of personal coach. Second one, study tracker. So by participating in study tracker plan and study booster workshops, we can evaluate your progress in bi-weekly reviews with personal coach. Evaluate your progress in bi-weekly reviews with personal coach. So these are the things you are going to be doing in by study tracker. Next one is third one, mains Q&A practice, question and answer practice. So to strengthen your mains answer writing, you can strengthen your mains answer writing capability through regular practice with evaluation and personalized feedback. So whatever the things you are going to be answering, questions answering here, your answers are going to be evaluated and providing a personal feedback to you. These are the additional things you get in iconic subscription compared to plus subscriber. Okay. Okay, now we are going to small signal modeling of transistor. First of all, what is small signal and how can you model a transistor under small signal conditions. Now we are going to that. So small signal modeling. Of a transistor. Small signal means it is of the order of millivolts. Of the order of millivolts. The example for this one is signal coming from cable. Signal in cable. Whatever the TV cable connection we have, in that signal is very small signal of the order of millivolts. Okay, that signal has to be amplified and present in as a picture in TV. Okay, for the small signal we need to model our transistor. How transistor has to be take or considered for that signal. Say this now. Okay, let us I am taking a properly biased transistor. Let us first drawing the transistor. I am taking transistor. I am taking two conditions, two cases. So emitter is grounding. Here I am connecting a resistor, and here it is connecting to ground through source. Now this is the circuit. That is RB and it is RC plus VCC. So I am copying the circuit. Now these are the two cases. In first case I am going to apply a DC supply. A DC supply. Second case I am applying a small signal. Small signal. Okay. Now this is the VBE. Just omit the drop across RB. For better understanding purpose, I am omitting the drop across RB. You can omit the RB. Capital VBE. That means a DC supply I am applying here. DC biasing voltage VBE. Due to this VBE, base to emitter voltage, because drop across RB I am omitting, or you can take RB equal to low value 0. Now, under these conditions, due to this capital VBE, some capital base current is flowing. Here some capital collector current is flowing, and here capital IE is flowing, and some DC output voltage is there. That means all are DC values. Capital in the sense it is a DC value. Here I am applying a DC voltage of the order of volts. Okay, then DC base current, DC collector current, and DC emitter current. Finally, DC output voltage, DC voltage VCE. Okay, now next case. Here what I am doing is small signal VBE of T I am going to be applying. VBE of T, small VBE of T. Small signal. Now for easy purpose, now onwards I am representing that one small letters VBE. Small VBE means, small means it is a small signal, very small signal like this. very small signal, like this, like this. Strength of this signal is very small. It is of the order of millivolts. Okay, let us take 200 millivolts for example. Okay, under these conditions, can I expect, listen carefully sir, can I expect due to this a small base current, small collector current and small emitter current, at the same time small change in output voltage or small output voltage VCE. VCE, small values, all are small values. Okay, now so here I am applying, it is of the order of volts, 2 volts, 3 volts, like that. Now all are DC values. These are the small signal, 200 millivolts hardly. Now small IB, small IC, small IE, small VCE. These are the possibilities. Now my question is, I am saying that it is fine. Is it okay or not? Is it okay or not? Here there is a possibility to get these currents or not? That's my question. Is it possible or not? Possible. That's my question. But sir, is it possible? Yeah, once think of it. Is it possible or not? Think of it. It is not, it is possible. No problem. No doubt at all. But once you are going to this, here it is not possible. Not possible. Why? Because strength of this signal is very small, 200 millivolts. To make this junction into on state, minimum of 0.7 volts required. So 0.7 volts means 700 millivolts. 700 millivolts. So that is a very small signal. Now with respect to this small signal, how can I model my transistor? How can I realize my transistor? How can I model it? Now we are going to discussing it. My intention is to process the small signal at output side. That's it. With respect to this, what is the small base current I am getting? What is the small collector current you are getting? What is the small emitter current you are getting? What is the small output voltage you are getting? I want all those things. But you are saying that it is not possible. Yes, not possible. Because the signal strength is not sufficient to drive your transistor. So to drive your transistor, minimum signal strength required is 0.7 volts. So but the strength is not that much. Only 200 millivolts. Okay, sir. Yes? Is it okay? Now, then what I want to do? What we do? Serious. Now, I am going to taking this signal, superimposing on this. It means, listen carefully, it is very important. This is the DC signal now. Superimposing small signal on DC signal. Now, therefore, to process small signal, it is superimposed on DC supply, DC signal. Now it is like this. This is your transistor. Now I am omitting the base resistor. That means I am considering only base to emitter voltage after that. Now is ground. Here resistor I am connecting. RC. Here I am connecting small signal is superimposing on DC supply. That's it. So this is small VBE and this is capital VBE. It is a DC supply. It is a small signal. Strength is of the order of 200. Okay. Now once we apply this, at input side I am expecting two currents. Due to this DC supply, DC current is flowing, base current, plus similarly here also DC collector current is flowing, and here DC emitter current is flowing. At output side also we have a DC output voltage, VCA. Now due to this small signal at input side, small base current is flowing. Output side at small collector current is there. Now another small emitter current, and output side small output voltage VCA. Okay. Now due to this capital VBE, capital IB, capital IC, capital IE, capital VCE, all these are DC components. VBE, see this sir, here VBE means, so VBE of T sir, it is a small signal, and IB means IB of T, I am taking IB of T as IB. Similarly IC of T is taking as IC, small signal. IE of T is small IE, and VCE of T, small output voltage, is VCE. So this is the notation I am going to be using. All these represent small signals. Small signals. Okay. Small signal. Okay. And one more, this is plus VCC. Don't forget that. That is plus VCC. Okay. Now I am going to calculating. Now my intention here is to calculate the small IB, small IC, small IE and small VCE, to represent these things equivalent representation of the transistor. How can we represent the transistor? That means modeling of the transistor. That is the things I want. Okay. Now see this, what I am doing here. Now see this. Okay. Now first of all, the voltage between base to emitter is, the voltage between base to emitter is capital VBE plus small VBE. Capital VBE plus small VBE. Okay. Now what I want to do is here first I am calculating collector current. We know collector current equation. IC is IC naught or I naught into or IS into reverse saturation current into e power VBE by VT. This is the equation for IC. Okay, now I am applying same thing on this. Therefore, total collector current is due to these two signals. Therefore, total collector current is capital IC plus small ic is equals to IS into e power VBE. Total base to emitter voltage is capital VBE plus small VBE. Capital VBE plus small VBE by VT. That's it. Now from this is the total collector current. Okay. Now I am writing, now it is capital IC plus small ic is IS into e power VBE by VT into e power small VBE by VT. Now this part can be written as capital IC. Therefore, capital IC plus small ic is capital IC into e power VBE by VT. Okay, here VBE by VT is small. VBE is small signal. Now VBE by VT is very small. So VBE by VT is small value. Here VBE by VT is small value. So once it is small value, then you can write e power VBE by VT as small VBE by VT as 1 plus VBE by VT. Therefore, total collector current is capital IC plus small ic equals to I naught into I naught into this. It is a capital IC into, already we converted. Capital IC into e power VB by VT, small VBE by VT. So now we are taking this is capital IC plus e power IC into, this is 1 plus e power 1 plus VBE by VT. Now it is capital IC plus capital IC into small VBE by VT. So that is capital IC plus small IC. Therefore, just equate both. Capital IC plus small IC is capital IC plus capital IC into VBE by VT. Just compare. Therefore, small IC is capital IC into VBE by VT. VBE by VT. That's it. Now, this is the small signal collector current. Okay. Now, therefore, small IC is capital IC into VBE by VT. VBE by VT. Now, in that, from this, I am taking small IC by VBE. Output current by small signal output current by small signal input voltage. That is transconductance, GM. Transconductance. Therefore, small IC by VBE is, from this expression, mod IC or capital IC by VT, which is GM, transconductance. Is transconductance. Therefore, transconductance of the transistor is IC by VT. So this is one of the important parameter. Everyone should be know it. So DC IC is a capital IC is a DC collector current. Already I mentioned, sir. These are DC values. DC collector current. Okay. Small signal parameters. Small signals. Now here I am writing those also. VBE. DC voltage between base to emitter or base to emitter DC voltage. Capital IB, DC base current. Capital IC, DC collector current. Next. IE, capital IE, DC emitter current. Okay, and capital VCE, DC voltage between collector to emitter. Voltage between collector to emitter. Okay, and small signals now I am taking. Small VBE of T, Small VBE we are calling that in circuit. That is nothing but a small VBE of T. Okay, it is the small signal between base to emitter. Small signal applied between base to emitter. Base to emitter. Small signal applied between base to emitter. Next, small IB of IB is nothing but a small IB of T. It is the small signal base current at base terminal. Small signal base current. Small signal base current at base terminal itself. Now, IC is IC of T. Small signal collector current. Don't confuse. Small means it is of the order of millivolts. Don't forget that. Small signal, it is base current. It is small signal collector current. Next, IE is small IE of T. It is small signal emitter current. Small signal emitter current. And small VCE is small VC of T. Okay, small signal between collector to emitter, or small signal output voltage. Small signal output voltage. Okay, or small signal voltage between collector to emitter. You can write anything, it's not an issue. So these are the names of it. Don't confuse. So far we calculated IC, and GM also we defined from this. Okay. Now from this I am going to writing IB. Now I want IB. Now I am taking base current. So from circuit, total base current is total base current. Total base current is from the circuit. Total base current is there they given capital IB plus small IB. Capital IB plus small IB. Okay, capital IB plus small IB. Okay, now we know one thing. We know the relation between base current and collector current, that is I B is IC by beta. IC by beta. Okay, now I'm applying same thing on this. Now total base current is equals to total collector current by beta. So we can write it capital IC by beta plus small IC by beta. Therefore capital IB plus small IB is capital IC by beta is nothing but a smaller capital IB plus this is small IC by beta. So by comparison, small IB is small signal base current is small signal collector current by beta. Just before we calculated small signal collector current, just use this. Therefore, small signal base current is small signal collector current by beta. Use it. And just before we calculated small signal collector current, we know small signal collector current value is capital IC into GM by VT, or mod I, just a minute. So it is a VBE, sir. Sorry, IC into VBE. Just once check it. Yeah, it is IC into VB by VT. VB by VT. Now capital IC by VT is nothing but a GM into VBE. So you can define any one of it. Any one of it you can use. Now I'm going to using this one. Therefore, small signal base current is small signal collector current is a GM into VBE by VT. By VT. That's it. From this, I am writing. So this is small signal base current. First of all, base current is GM into VBE by VT. Okay, now I'm taking that one into a compact form. Taking that one into compact form. So just you get IB is GM into small VBE by VT. Okay, now I'm going to representing from this one parameter, that is VBE is a small signal input voltage by small signal input current is IB. Input voltage by input current, it is a small signal input resistance. Small signal input resistance or input impedance, which is represented by a parameter R pi. It is represented by a parameter R pi. Therefore, I am defining R pi as, from this, VBE by IB. Just VBE by, take this IB this. Now GM by VT it is. That's it. GM by VT. Okay. GM by, just a minute, sir. Sir, it is GM by VBE. Sorry, sir, it is beta. All confusion, sir. It is beta. Sorry, it is beta. GM by beta. Next. Now, so we know the values for it. I am going to take another value. That means in terms of VT, I want to represent R pi, because in problem they may give any one of it, any parameter. So now I am taking this. So R pi is, just before we define, GM by beta. We know the GM just before we calculated mod IC by VT, and beta we know that IC by IB, capital IB. Now this IC gets cancelled. Therefore, small signal input resistance is nothing but a capital IB by VT. That's it. This is the another equation for R pi. Okay. Another equation for R pi, IB by VT, that is the R pi. Is it okay? Like that we can calculate whatever the parameter we need. small signal parameters in transconductance we calculated, and here DC parameters. So once you bias your transistor, there from that you can easily calculate the small DC parameter. That means terminal currents you can calculate: base current, emitter current, and collector current. So beta they will provide. So, and from IC, capital IC, you can get the GM value. Once you get the GM value, they will provide beta. From that you can calculate R pi easily. Okay, so small signal parameters also we can easily calculate from this. That is the beauty here. Okay, now based on this I am going to defining a model, that is, so see this. Now you are saying R pi is VBE by small ib as well as GM by beta, and at the same time IB by VT. IB by VT, capital IB by VT, and small signal collector current is GM into VBE. Okay, now by represent these two, I am going to drawing the equivalent circuit of the transistor by promoting these two. This. So I am taking this is base, it is emitter. So small signal base current IB, small signal voltage between base to emitter is small VBE. Now VBE by IB is equals to R pi. So it is R pi. Now at output side, here we have collector resistance, collector current. IC is GM into VBE. So GM into VBE. So in terms of transconductance, I define it is IC, small IC. It is emitter. That's it. This is called R pi model representation of the transistor. R pi model. Okay. And at the same time, we have a property in transistor. We have a property in transistor, that is base width modulation. Okay. So in this diagram, they did not specify the base width modulation. So this is the R pi model by omitting base width modulation. Here they omitted the base width modulation. They did not highlighted that by omitting base width modulation. And one more, sir. This is VCE. By omitting base width modulation, this is base width modulation. Now, by considering base width modulation, how can we draw the circuit? See this. Simple. Take the input part, no change in the input part. At output side, is GM VBE. So base width modulation is by changing the output voltage, output current is increasing, collector current is increasing. So to represent that, that means VC directly proportional to IC. So to represent that directly proportionality, I am adding a resistor here. Okay, that is, let us take RC. Is R pi base emitter, collector emitter. This is a small IC. This is small IB, small VBE, small VCE. So this is a R pi model by considering base width modulation. Okay, R pi model by considering base width modulation. by considering base width modulation. That's it. So RPi model by considering base width modulation. Okay, is it okay? So like that you can define your transistor. Okay, and how can we get the RPi value or RC value, what you are represented there? How can we represent it? What is the value of it? Okay, see whatever the H parameters, and there is a similarity here. Okay, now that similarity is you can write this R pi or R naught. R naught. Now by compare, we can compare these things with H parameter values also. Here R pi is nothing but a your H parameter HIE, and beta is nothing but a HFE, and whatever the R naught we are representing here, which is nothing but a 1 by HOE. This is the representation of these parameters in terms of H parameters. Okay, and this model also called as this R pi or pi model. Sometimes we called it pi model also, pi model or R pi model. Sometimes we call it is also called as pi model, also called as common emitter model, called as common emitter model. Common emitter model. Okay, so we can easily analyze all the parameters from the knowledge of DC analysis. Okay, by doing DC analysis, so you can get the everything whatever you want. Okay, and the value of R naught is represented another way, that R naught value is whatever the early voltage we have plus whatever the DC output voltage VCE we get, that one by IC. Here VA is the early voltage. Okay, so early voltage it is. The value of VCE at which base is filled by depletion region, that is the early voltage. By using that you can calculate this value. Is it clear? This is the R pi model representation of the transistor. Okay, now here regarding with respect for VGS is the new one. Now I am going to representing some information regarding GM, transconductance. First point is here GM is increases linearly with collector current, whereas in FETs or in FET, you can take any FET, GM increases parabolically. Increases parabolically with IDS, with the drain current. Okay, next, second one, GM increases linearly with the collector current and increases exponentially. GM increases exponentially with respect to VBE. Exponentially with respect to with VBE, whereas in FET In FET, GM increases linearly with VGS. Linearly with VGS. Gate to source voltage. Is it clear? Next. Here one more. In FETs means two FETs we have. Here GM is increasing linearly VGS for MOSFETs. Okay, and GM decreases linearly with VGS with VGS for JFET, because of 1 minus VGS by VP there you are getting. So it is GM varying, instead of increasing, varying I am taking. GM varies. Varies. So once again see this, GM increases linearly with the collector current, and whereas in FETs GM increases parabolically with IDS, that means drain current, and GM increases exponentially with VBE, whereas GM varies linearly with VGS. Okay, now here with respect to IC also is there. Now IC, as IC depend exponentially on VBE, exponentially on VBE. Okay, but because of that BJT have greater transconductance, because of this greater transconductance. Greater transconductance than FET. Than FET. IC depends exponential on VBE. Because of that, BJT having greater transconductance compared to FET. This is the information related to GM and IC. Okay. Now we check once. See, Tiwari sir, he is the IIT topper. He has 7 years of GATE and engineering service exam, and he is the author of the book GATE in 75 days. Ankit Goyal sir obtained All India first rank twice in GATE Electrical. He was awarded President of India in gold medal in IIT Indore. Jaspal Singh sir, ex-IAS officer, got All India 4th rank in that, and Sanchit Jain sir, experienced faculty in computer science. Here are few more top educators from Unacademy. Now these are the different engineering disciplines available in Unacademy. And there are two plans, plus plan and iconic plan. Both the case, India's best educators are handling your subjects. Interactive live classes, structured course and PDFs, and live tests are there. Here we are showing the difference. Once you've written the test, it was forwarded to your personal coach. Now personalize the test analysis, perform on that. Study planner they will provide and prepare. Respective material they will provide. Now plus plan, it is available in different subscriptions: 1 month, 3 months, 6 months, 1 year, 1.5 and 2 years. As a faculty, I recommend to take 1 year. By using my code VRAU10 during subscription, you get it by 10% discount. Same in Iconic also, there is 1 year and 2 year subscriptions, only two types. For 1 year subscription, it is 50,250. By using my code VRAU10 during subscription, you get it by 1 year, 10 months, 10% discount. And thank you. Thanks for spending your valuable time with us. Don't forget to use my code VROUT10 during subscription. Please subscribe us and join our Telegram group for getting latest updates. Hit on the bell icon for getting notifications. Please give your valuable comments on YouTube. Thank you. Thank you very much. Thanks for spending your valuable time with us. And I'm thanking Unacademy to providing such a beautiful facility to share the knowledge with you.